So, hello, we're LLC number 1 and we'll be talking about building simulation. Next slide. So our name is Popcorn Professionals. Cameron worked on the energy modeling benchmark and upgrade. Andrew also worked in the same thing. And Alexi too. Brittany and I worked on the PPD analysis, and Brittany worked more in depth with the presentation. Next slide. So this is the residential building baseline model we did with all the things in the scope of work, which is the 1,600 square foot. Let's go back. Wait, what? One more. Yeah, what the scope of work said for a baseline model, which is the 1,600 square foot story single family house with the regular air conditioning, gas furnace, and the schedules of a regular household with people working from 9 to 6. And the only thing we did different is that the weather data is from Seattle because the Salt Lake City one was not available. And yeah, next slide.
Tomas, if you can hear me, your audio is not very great. I don't know if you can pass it over to another team member, but right now we're not hearing you at all.
I can explain this. This was our original baseline model that we created of the house, and we tried to input some less energy efficient, basically like concepts into the house so that there was a lot of room for improvement. So for example, the original house only had single paned windows. It had inefficient appliances, heating, cooling, and only fluorescent lights. So we wanted to start that out of a baseline of being not energy efficient, but also meeting the square footage and the number of occupants and the specified location that we had. And these are the energy MMBTU and the cost dollars per year associated with that old benchmark model. And then here are also some monthly energy usage trends. You could see the comparison of our model to regular baseline. So they're pretty similar. You could see it gets very erratic in November and December, likely because of heating kicking on incrementally.
Okay, these ones are mine, right, Cameron?
Yeah.
Okay, so some of the upgrades that we thought we would implement, we thought we would just go all out and do as many as we could, but replacing the single pane windows with double pane windows, lowering the heating set point and raising the cooling set points of the thermostat in the household, improving the R value of the building insulation, improving the heating efficiency, installing some sort of renewable energy system, upgrading the fluorescent lights to LEDs, and then switching our appliances to Energy Star rated, more efficient appliances. So here is the new house with the upgrades versus the same baseline model that it was showing before. So we had a little bit of an improvement. And then here's that same monthly trended data of the BTU usage of the baseline model versus the new improved energy house. And so here is our cost benefit analysis. So we very loosely costed out each of the separate things that we did for the upgrades. And it totaled out to $6,400, which is a significant amount more than we were saving. So overall, our upgrades were a little bit more cost effective than they would be worth, but it's because the payback period was a little bit greater than the lifespan of the different things that we were implementing, but that is the cost benefit analysis.
Yeah, I'm wondering that like for this cost benefit analysis, so where does the cost come from? Like, is it just a rough estimate?
Which cost? Sorry.
Yeah, the implementation cost.
It is
So,
a very rough estimate of things that we Googled. So
okay. And then so for the lifespan, so how do you get that? So I guess
that was also a rough Google. We just Googled average lifespan of dishwasher and stuck it in the slideshow. So it's all very up for interpretation. It was just a very rough analysis.
And my question for you is, are you using replacement costs or incremental costs for these? Because a lot of times, if you're looking at incremental benefits, you should use incremental costs, which is how much more expensive is an energy efficient dishwasher compared to a normal dishwasher? Because you're going to have a dishwasher either way.
We assumed that the house had like not great appliances and that we were upgrading to better appliances. So it's the full cost of getting a brand new one, but incremental would be smarter.
That does not include any incentives either, which upgrading to Energy Star appliances and light bulbs, maybe not in a residential setting, but in a larger commercial setting, you could get like rebates out of that.
Yeah, because I also feel that this lifespan is a little bit longer than I expect, for some of the measures possibly. Yeah. So
I went out of order in the slides here, but we did do the building performance database analysis to follow up that cost benefit analysis. There was quite a learning curve working with this website. However, it is really interesting. I think we just had a misconception of what it was actually used for. We spent a good amount of time trying to load in our own buildings with all the specified parameters, like 4 occupants, 1,600 square feet, and we're not getting any output graphs. But after talking to Dr. Chen, it seems like the BPD website is better used as just a baseline. They have tons of models, commercial, residential, office spaces, hospitals that you could compare your own building model to and look at those energy usage. So the graphs that I've provided here are reflective of kind of like our old model, one that had an evaporative cooling unit that was residential between 1,000 and 2,000 square feet. And it basically just gives you a lot of data about like emissions intensity. Yeah, so that was a cool tool to do our comparison with, and it's definitely useful. We just were using it wrong to begin with. So, sorry, go ahead.
Like, how's your simulation results compared to what you have seen in the database? So
our measured results, it seems like our building used higher amounts of energy. That was something that I played around with when I tried to load my own building into the BPD software. We found that our house was actually not super efficient, and you could see that based on the cost of implementations. Yeah, we did have a little bit of trouble comparing it because the graphs that are output in the BPD website aren't necessarily reflected in the BOPT software. So if you have any advice on that, that would be great on how to further analyze this.
Yeah, so I think basically like in the BOP, you can come up with some normalized measures, for the building energy use, such as, this energy use intensity. So, if you can compare to the database, the data, that is the actual measurement data from different buildings in a real scenario, you might get a rough idea. So I think that's maybe one of the best way you can utilize what is existing, in the database, and trying to benchmark your simulation. And then another thing that I think you can possibly explore is, when you try to input different characteristics in this BPD database, and you will see, how these normalized measures of building energy use will changes, with different characteristics. Because I don't know, I think for you have mentioned a couple of retrofit options. I don't know which retrofit options do you guys find has the most effective ones, in your simulation. So
I found that
Yeah.
When I was able to independently change variables or specifications of the model houses, just like you said, and I did see that energy usage decreased when you switched out single pane windows for double pane windows or
Yeah.
fluorescent lights for LED lights. So it was much easier to see the energy savings when you switched one parameter at a time on the baseline model.
Yeah. So basically, you think that you find that the Windows retrofit might be one of the most effective measures, to reduce the energy use, right?
Right. I think the appliances definitely had a big factor in reducing energy usage, but that was one thing that was harder to navigate on the BPD website because they have so many options for types of boilers, air conditioning, HVAC units. But it's super thorough. It's definitely something to look into further.
Okay, cool. And I don't know, like, have you guys also considered maybe retrofitting you building envelopes, like the exterior wall, like put it into different insulation levels?
That is not something we considered because we wanted to keep the structure of the house the same, but I saw that there are places to change the R value of the walls and the insulation of the walls on the BPD website, and I'm sure that would lead to a lot of cost savings.
Yeah, and also you can change this, I think, very easily, like in the simulations, in the BOP that you can use. So yeah, you can try to compare it, with the code standard building, about, how these different kind of settings or different insulation levels of your exterior wall, or maybe, your ceilings, will impact on the energy use. Yeah. In addition, to the windows could definitely be a very big part. Yeah.
I just had a couple of questions for anybody that wants to answer them, including Dr. Chen. Andrew brought up, how would changing the direction that the house faces, whether it be east or west, affect energy consumption? And how could you justify a project like this that has a payback period longer than its lifespan?
Yeah, I don't know, like, anybody have any thoughts on this?
So Cameron, I'll just jump in on the first one. That first question is a great question, and it's actually one of the, when you're doing more what I would consider basic building design, especially around energy efficiency and renewable energy goals, that orientation of your building is definitely one of the core considerations of how to maximize your energy efficiency. And generally speaking, the short answer is it does affect it. It does affect both heating and cooling. Sort of a rule of thumb is to orient buildings when you can. Oftentimes, you're inheriting a lot or a place where you're building that you can't do a lot with the orientation, but there are optimal ways to basically orient buildings to be able to minimize energy efficiency and as well as maximize renewable energy production. So that's a great question.
Yeah, and I think just adding a little bit more on that, and for the typical case that we perform the building simulation, and the orientation of the building is definitely one thing that we can explore. What are the optimal orientation of the building that will achieve the most maybe energy efficient building design? Because this question is also related to where you want to put your windows. Because with the same orientation of the buildings, and for example, if you put your buildings, maybe a large surface of your buildings on the south, and that surface will have a lot of windows, and you can expect a lot of solars will be transmitted to the indoor environment, and that will also have a very huge impact on your energy use. But on the other hand, the more solars or more visible lights coming through the window will possibly reduce your energy consumptions for the lighting systems, because you tend to rely less on that. to provide the same level of the illuminance, of your buildings. So, basically you can see the orientations of the building, coupled with other building design, like where the windows and what is the HVAC system, and also the lighting system. It will be a very integrated problem. So that if you're running through some energy simulation, you will definitely get a better idea of what are the trade-offs from each aspects in the design process. So.
Actually, I have one follow-up question, Cameron, for you or any of the, is it popcorn professionals? Did I get that right?
Yep.
Were you in BOP able to change your orientation of the simulation house? And did you, if you were, did you see any impacts from it?
So Andrew was the person that had the BOP software on their computer, and he was the one that actually brought up that discussion. I believe that you are able to change the direction of the house, and he purposely faced it east for no reason at all, but we didn't change the direction of the house when switching to the upgraded model. So that was just like a theoretical question that we had, but we definitely could do that and see if there are energy savings.
Yeah. Dr. Chen made some excellent points there, Cameron. And basically my point is to you and the group that with this type of software, you can actually do those things and see results directly to answer that question. And it might be interesting for you all to try that out.
Yeah, you should definitely be able to change that, in different simulation runs. Yeah.
Sweet. Awesome. Well, thanks, Julie. Thank you, Dr. Chen.
Also, I just wanted to reiterate on your second question here, which is also a great question. In residential energy, you've all probably heard me say you have to spend money to save money. And in residential applications in general, relative to the commercial and especially the industrial applications that you all are getting introduced to through IIAC, the dollars are a lot smaller in residential. And so it's a particularly important question that you're asking about how to basically make the cost benefit argument for energy efficiency and renewable upgrades to houses. Michael made a great point a couple slides back about, especially when you're building a new building anyway, like what we're looking at here, you're going to be making purchases of appliances or envelope or any of the other aspects that you've talked about today. You're going to be building a base model. You're going to be purchasing something. And so really in a new construction, especially, the point is to look at the incremental differences between the costs as well as the savings of energy efficiency attributes that you might be considering. So considering that incremental cost is a key to that second question, and as well as incentives. Rocky Mountain Power and most of the utilities throughout the US do have incentives available to the residential sector. So those are both good ways to help justify these improvements. Good questions.
Yeah, and also just a little bit add on that is, for the lifespan, like the life cycle benefits of different retrofit options, it's also something that varies across different climates. Because currently you are just simulating, one climate, and that is Seattle. I would expect the weather there is not that extreme, or maybe it tends to be a little bit mild. But if you simulate different retrofit options, in other climates, for example, if you simulate envelope retrofit or insulation improvement in the envelope, maybe in a climate like Minnesota or maybe in Utah, and you will definitely see very different results, for different options. So that's also very important factors, to consider. For example, in cold climates, you might want to think more about maybe increase your insulation levels. But in some hot climates, because in this type of climate, the cooling will be very dominant, then maybe some factors that you want to consider to control will be related to your windows. How you want to design your windows with maybe a relatively low solar heat gain coefficient, so that it doesn't add a lot to your cooling load. So you can see, different retrofit options might be in a very different effectiveness level in different climate zones. So, possibly that's also a very critical point. When you just say that, oh, the payback period is too long. So it's, all depends and it all varies. Yeah.
Great point. Okay, Cameron and group, anything else that you guys have to present or talk through?
No, I think that's all we had.
All right, fantastic. Thank you. I appreciate you
Thank
guys
you.
going first. So let's switch over to our second group and for today, and you all can take it from here.
Right. Me. Does that look okay?
I'm seeing your
Yes.
slides just fine. Yep.
Great. So we are the re-energizers. So I was building improvement strategies as well as Lizzie. She worked mainly on the PowerPoint I'm going to be presenting to you today. Mateo also helped with building improvement strategies, and Sammy was the one who created our baseline model. So base model based off of the BPE, just our base model. After putting it in, we got our energy uses was about 139.9 million BTUs per year. And it had a total cost for energy related things that we had per year. And this was using Seattle as the location, obviously, because the server that is trying to connect to download Salt Lake doesn't exist anymore. And so we spent some time trying to figure out how to download that, and it didn't work. So we just stuck with it.
Hey, Alex.
The benchmark results, say what?
Alex, actually, that's a great slide. Let me go back really quick and point something out that this slide brings up. So total costs here are basically just over $1,300 a year, right?
Mm-hmm.
And that is for electricity and gas?
I believe so, because it's counting the heating as well in that energy usage.
Okay.
I don't think it had a separate one for gas. I believe this would count the gas for the furnace as well.
Okay, awesome. So we're gonna do a quick vetting here. How many, show of hands, you guys can use the reactions on your Zoom. How many folks here actually pay their utility bill for where they live right now during the academic year? Actually use the reactions on so I can see a little better. Ellie, if you can see everybody, I'm curious if you could get a quick count. I can only see partial.
I only pay
I
electricity.
think it's 6.
No gas.
Yeah.
So I'll make it even more general and say, if you pay any, raise your hand if you pay any of your utility bills during the year. So we have a lot of hands in short, right, Ellie?
Yeah, 6 or
Oh.
7 hands.
Okay, so basically what campus housing does not count, true. Basically what Alex is proposing here is this residential model that they're using. Their total utility bill per month is $110. That's gas, assumedly gas and electricity. So I'm just curious, clear off your raised hands. If you pay your bill, is your bill $110 a month? How many of you pay $110 a month or more? I see Mateo has his hands. Cameron, you pay more than 110. Okay.
I
Sorry,
live with 5 girls, so
I had my hand up, but sorry, I forgot to put it down.
Of course, this building is a pretty good sized building, so I don't know how it compares to your house, but is there more people than Cameron that have their hands raised? Dr. Chen?
I pay more than that.
Lexi says she would cry if her bills were that high. But nonetheless, it's an interesting exercise, Alex. It tells us that you're at least within a reasonable range. I would say it's not like anybody is freaking out that you're paying $1,000 a month or something like that. So good exercise. I personally live in a place where I haven't turned the heater on all winter. Of course, I keep it at about 65, but I don't pay utility bills in the winter, so I pay a lot less. Yay.
Yeah. So, I mean, obviously, it's pretty close.
Yeah,
me look
so within
through the
striking
logo.
distance, we would say. Cameron, I
Mhm.
don't recall off the top of your head, do you remember what your total dollars came out to for your model?
I don't. I could check right now though.
Okay, post it in the chat. Thanks, Alex. Just wanted to do that
Yeah.
little reality check with everybody.
Yeah. So our base building, it gives it in kilo BTUs. It's like 81 per square foot per year. But the BPE, based off of, messing around with that, it turns out the average is about 67. So, I mean, obviously there's some improvements that we could do for this house based off of the things we were given. So the first thing we did was temperature set points. We took and while people are gone, we increase them or decrease them depending on cooling or heating. And you can see our two graphs right here. We've got our building, which is the 139.9, and then it would be 136.7. So we're saving about 3.2 million BTUs per year. And so that's like $36 that you're saving. And you can see the graph is showing you in source energy savings in percent per year. So you're saving like just over 2% per year. And so it's not going to cost you anything, but you're saving about $36. And so that's a pretty good thing that we can do. As well as the other one that similar to the other group, we decided to switch to LED lights rather than what they were right now. And so there's about 5.3 million BTUs per year. And so that's like $35 you're saving, but to the cost, based on actually in the software, in the baseline model, it shows you the cost for different things of implementation even. And so it said the cost was about 112 to implement all the things with lights. And so the payback is about 3 years. And so, we said it would be lower with incentives, but that's also not a bad payback period. And then the last thing that we kind of messed around with, because we were trying to figure out a couple things, was, what if we changed a refrigerator to be, more energy, not as energy intensive. And so we switched to a different refrigerator that we thought would be better. And it ended up with 1.5 million BTUs, which is about, $9 a year. But the refrigerator would cost an extra $525 more than what an original refrigerator would cost. So if we were just moving into a house at the same time, then, we needed to get a refrigerator, it was a difference of $525 than, the original one. And so the payback period is like 58 years. And so we think that if a refrigerator could last that long, then maybe it'd be worth it, but we don't think it's worth it. So based off of, those 3 recommendations, our, questions were what other things or inputs would have an actual good payback in residential settings, besides, lowering set points or switching out the light bulbs. What things are actually, good to implement?
Yeah, I think for this question, maybe I have already answered quite a amount of it. This really there is no universal solutions, across all the climates, and you should definitely take the weather conditions into account when you're trying to propose different retrofit options. But I think a very good point here that you mentioned here is actually the set points, and the list doesn't have any like implied cost, but it will save quite amount of energy for you. I don't know like how many degrees do you decrease you set points maybe in the winter? So
I think what we did was in the software, it's like the lowest amount you could go or the highest amount you could go for the set points. But it was, they have a specific setting that you can say, it will be this set point for most of the time, like a good solid, like the average, but then from 9 to 5, it will either lower or raise. So it even included that in the software. That's what we used to just say, while they're going to work, we'll just make the set points lower or higher.
Okay, yeah, because I think like for some of the cases, and also, yeah, it depends on different climates. By just lowering the set points by 2 or 3 Fahrenheit, in the wintertime, we even provide you a much higher cost savings, from what you have shown. So that will be a very good point, no cost, but it achieves quite amount of energy savings. And yeah, maybe the other thing that I want to very briefly maybe raise your attention here is about the lighting. And I think that's also a very good point. If you reduce, if you replace your traditional lights, with the LED lights, and yeah, possibly it will have, on one hand, you will have a direct saving on the lightings. And while on the other hand, you will also expect that it will lead to much less cooling loads, of your lighting. So that, if in these cases, it's in a very cold, it's in a very hot climate zone, it will also even help you reduce some of the HVAC size. So that this will be also very effective strategies. Especially, I think in commercial, it's one case for many residential buildings, because lighting will constitute a very significant amount of portion of the energies, of the whole building energy use. And this will really save you, on both ends. But in some of the heating climates, if you replace lighting, and then it means that you might need a little bit more heating loads. So it's another trade-off there that you would like to consider, in these retrofit options. Yeah.
Okay, thank you. Our second question kind of goes along with what you were already talking about. It's just, difference between residential areas versus manufacturing facilities. Sometimes the recommendations, well, they're going to be a lot different, like we talked about, cost-wise, a lot smaller numbers. But I mean, are there other challenges that affect, finding good recommendations besides, just different processes? So.
Yeah, I think manufacturing definitely it will be very different. So yeah, manufacturing, they have a lot of energy use in the manufacturing process as well. So I would think that, in you guys are like assessment or retrofits, a lot of energies, or a lot of assessments recommendations or improvement recommendations will go to the manufacturing process. Instead of in the residential buildings, it's more like just our regular use of the energy. And yeah, it's kind of it's a very different spectrums of the energy compositions, in two different buildings. Yeah.
The other big difference between residential and commercial energy modeling is that residential rates are usually just for kilowatt hours. Commercial rates usually include that both kilowatt hours at a lower rate and the kilowatt demand. So you don't care so much about like peak shaving or load limiting for a residential application, but you would probably for large commercial buildings, even large industrial applications, they'd be just as interested in avoiding, using time of use schedules, or avoiding running their chillers during the peak hour of the day if they could. So that makes a big difference too.
Yeah, it could be really significant in both commercial and manufacturing, if you're considering this peak demand compared to residential. Yeah.
Re-energizers, I'm actually curious, how did you all define your rates in your modeling, your electricity rates?
Or these ones, you mean?
Mm-hmm.
That was based off of, so the graphs that they give you, you can change the X values and the Y values. And so it shows you, you can't really tell, but on this one, where that gray line is, if you look at the graph, there's like a gray line, and then it's got a dot that is like in the bottom left corner, and then there's the dot on the other side. So let me like this one, it shows you, the difference of cost per year just on the graph.
Yeah, but I think you can also like raise a place that you can input different rates and then see, how like the annual cost will varies under different rates. Yeah.
Yeah,
I don't know
we
whether you
didn't
guys-
really, we didn't mess with the rates too much, but.
Oh, I see.
I think the model had a preset rate for whatever location you chose that you could change, but we didn't mess around with it at
Oh,
all.
okay.
Yeah,
Correct.
That's true.
That's an interesting point of comparison. Cameron, do you know, for your model, did you change rates?
No, we didn't change the rate.
Interesting. So we probably ended up using the same rates. I'm just curious now that you all, so basically your two models had the same, some basic definition to it. Now that the two groups have seen each other's presentations and models, is there anything that jumps out to you all? What was different? Why things would have been, let's just say the base cost, for example. What do you see there that would have prompted a different base cost? So basically one model is about $1,200 a year, right? And the other one is pushing $350, which in the residential or in the industrial sector, those aren't big numbers, but for residential, that's a pretty good percentage. I'm curious if you all noticed anything different between your two models. Any thoughts? Sammy, Lizzie, Alex, and Cameron have been doing a lot of talking. I'm curious if anybody else could chime in on that from your teams. Dr. Chen, did anything jump out at you?
Yeah, I'm not completely sure like what are the specific and detailed settings, for these two models. So yeah. I don't know, possibly like the systems that you choose are maybe are different across different models. Yeah, not completely sure.
Can you guys show your upgraded model slide one more time?
Yes.
So our cost, like our utilities per year, was $978 for our upgraded model, coming from about 1,300. So it seems like we have pretty similar savings. We made pretty similar adjustments to the upgraded model.
So most likely something in how you define the base models. Interesting. Okay, good. Alex, I didn't want to cut off your presentation there. Did we get to the very end of it?
Just if there was any questions. So
Awesome. Well, I have one group question then for anybody on the phone, whether you just learned the BOP building modeling in the last week, or if you've done a little bit more simulation. I'm curious if anybody would comment on the experience that you've had and an application or a situation for the IIAC where a simulation model for the might be helpful. I'll say one sort of caveat to that question is that generally speaking, simulations are probably more involved than we need to or would ever get into on a regular basis. But I'm curious if now that you've worked with it, or if people have worked with it in the past, if they throw out some ideas about where we might be able to apply some of this to our AR development. Any thoughts?
So
Sorry, I think that, for example, if you were to try to model a facility, you would need to really know or get to like maybe have a lot of information from the facility that we sometimes don't get.
Agreed.
And right.
Yeah, agreed. 100%, Mateo, to your point. So I'm curious if you saw any specific applications that you could use it though.
So I have actually done energy modeling for assessments twice, and both times they've been for facilities that have a little data closet. Like they have a split system serving like a server or an IT room. And the recommendation was to raise the temperature set point just for that server room, because servers typically operate 24/7, 365. And usually people aren't even in the server room. It just has like the switches and the routers and the, all that stuff. So I've done really, really simple energy models and just had basically that one space with like an electrical load and then a really simple HVAC system. And the only change I made was the set point in that room, because set points are so hard to calculate anyway, but this is kind of a special case with server equipment. So they're really small recommendations, and I made really, really simple energy models, but it worked pretty well.
Yeah, great, awesome.
And you simplified your insulation, all of that.
Yeah, I used default libraries for the types of places we were looking at. So I just did one for a high school in Moab, and I just used a default secondary school library in OpenStudio. And those types of features don't matter that much if you're keeping them consistent between your baseline and your proposed runs. So as long as they're consistent, you're not messing with the insulation value, so you're not getting, that's not contributing to your savings or your losses.
Trey, I see. Thank you, Michael. That was a great example. And I saw Trey put up his hand. You have a question?
No, I just had a possible application.
Oh, okay, go for it.
So I've been doing an assessment where I didn't know the HVAC usage of the building, but it was interconnected with the process use on their chillers. And so it might be a way that you could kind of estimate the amount of chiller that, or the amount of the HVAC would use the chiller. Not an exact number, but give you a better approximation.
Yeah, I can see that. Like Mateo said, to put in a lot of detail is probably not realistic for any of our assessments, but I could see some kind of relative sense of difference between the two. Any other thoughts?
Yeah, I think like for generally for the building energy model, and definitely in many cases, we need to use some defaults or maybe our best judgments. Because if you really see the parameters across the models, and it could be tens of thousands levels. So this could be ready to be checked in all details. But as long as we are kind of grasping the main lines of that, and also and it could be especially also useful as Michael comments, in some relative comparison, and it works pretty well in many of these scenarios. And also like in our actual usage of the building energy modelings, especially for some kind of real retrofit project. And we also need to go through another process that we call is the building energy model calculation. So that's a process that we have collected the utility data back, for the buildings, and then we are trying to put it as an optimization problem, and then we are trying to adjust our input parameters, the most critical sets of the input parameters, so that our simulated results will be as close, to the actual measurement as possible. Then after we are calibrating our models, then we have more confidence that our models is reflecting the ground truth, and then then we can begin to manipulate or play with different building parameters to come up with different retrofit options. So that's maybe another process that can be beneficial or could be utilized in the actual project is the calibration. So yeah.
Fantastic. So Dr. Chen and I are going to talk about doing sort of a, you all just got a crash course in building simulation 101. And we're going to talk about possibly in our fall semester, expanding on it a little bit and maybe giving you a crash course in building simulation 201 or 301. So I'm glad that we were able to get you this introduction, and I see that we're already over time for today. So time does fly when we're having fun. Dr. Chen, thank you very much for the last two sessions. Is there anything you wanted to say in conclusion for today?
Yeah, I also appreciate the opportunities for presenting here, and it's really great to see that. I think this is maybe one of the simplest thing or simplest modeling that you can do is using BOP. But it's good to see that you are kind of developing some initial thoughts, and also begin to familiar with some most basic concepts that we utilize in the energy modeling. And I think that's also the idea of this session, is to just to give you guys some heads up about what is actually going on. So yeah, it's good to meet with you all. Yeah,
fantastic. Nice job to both LLCs this week, and we'll call it good for today and see you next week. Thanks all. Have a good night. Bye-bye.
Thank you.